वेलकम टू एस पी स्मार्ट डिजिटल। बच्चों, यहाँ पे मैं फ्लूइड मैकेनिक्स में विस्कोसिटी से रिलेटेड कुछ क्वेश्चन जो कि प्रीवियस ईयर जेईई मेन में आए हुए हैं उसको मैं डिस्कस कर रहा हूँ। जैसे अगर फर्स्ट क्वेश्चन यहाँ पे हम देखें तो है ए स्मॉल स्फेरिकल बॉल ऑफ रेडियस आर फॉलिंग थ्रू ए विस्कस मीडियम ऑफ नेग्लिजिबल डेंसिटी हैज़ टर्मिनल वेलोसिटी वी डैश v, terminal velocity v. Another ball of the same mass but of the radius 2r falling through the same viscous medium will have terminal velocity. उसका terminal velocity क्या होगा? So we know that अगर density negligible है, buoyancy force will also be zero. buoyancy force तो हम क्या मानेंगे यहाँ पे जीरो मानेंगे। तो terminal velocity में क्या होगा? weight of the sphere, weight of the sphere, spherical ball बोल लो, a spherical ball is equal to viscous force, so weight of the spherical ball कितना हो जाएगा mg and viscous force is equal to 6 pi neta r into v. So this is equal to v is inversely proportional to 1 upon r. So according to question radius क्या है, डबल हो जाता है. So this is v upon this is v dash is equal to this is r dash upon r. So this is equal to given है r dash is equal to 2r. So this is equal to v upon v dash is equal to 2r upon r. So this is equal to v dash and v dash is equal to this is equal to v upon 2 and this is the correct answer. Now next question. A small ball of mass m and density rho is dropped in a viscous liquid of density rho naught. After some time the ball falls without constant velocity. The viscous force on the ball is, जो viscous force लगेगा बॉल पे वो कितना होगा. So this is the sphere and this is the buoyancy force Fv and this is the weight and the viscous force in the downward direction. Now viscous force Fv is equal to weight minus buoyancy force. So viscous force is equal to mg minus v rho naught into g, buoyancy force. So this is equal to Fv is equal to mg minus volume is equal to mass upon density into rho naught into g. So what is Fv? So Fv is equal to mg, कॉमन ले लिया हमने. So this is 1 minus rho naught upon rho. This is the viscous force. So viscous force on the ball is, so this is mg into 1 minus rho naught upon rho. So D part is the correct answer. Now next question. A spherical ball of radius 1 millimeter and density 10.5 gram per centimeter cubic is dropped in glycerine of coefficient of viscosity 9.8 poise and density 1.5 gram per centimeter cubic. Viscous force on the ball when it attains constant velocity is 3696 into 10 to the power minus x Newton. The value of x is g is equal to 9.8 meter per second square and pi is equal to 22 upon 7. So we know that mg and mg is equal to this is equal to viscous force and plus buoyancy force. So viscous force is equal to this is equal to mg minus buoyancy force, as given in a question that acceleration is equal to 0. The ball attains constant velocity means acceleration 0, मतलब एक टर्मिनल वेलोसिटी की बात कर रहा है यहाँ पे. So this is equal to Fv is equal to this is equal to what is mg. So this is v sigma b into g, density of ball, minus v rho into g, density of liquid. So this is equal to FV is equal to viscous force, and viscous force equal to, this is equal to VG, V into G into sigma B minus sigma B density of ball minus density of liquid. So this is equal to, if we putting the all values, so this is equal to V is equal to 4 by 3 pi r cube volume of the sphere. So this is equal to 10 to the minus 3 का whole cube, because 1 millimeter and 1 millimeter is equal to 10 to the minus 3 meter, the whole cube, into acceleration due to gravity is 9.8 into 10.5 minus 1.5 into 10 to the power 3. So FV is equal to, this is equal to 3696 into 10 to the minus 7. So if you are comparing the this FV with this equation, so 10 to the power minus x, so what is x? So x is equal to 7. This is the correct answer. Now next question. Next question is, if a ball of a steel density is equal to 7.8 gram per centimeter cubic attains a terminal velocity of 10 centimeter per second when falling in water, coefficient of viscosity is equal to 8.5 into 10 to the minus 4 pascal second, then its terminal velocity in glycerine density is equal to 1.2 gram per centimeter cubic and coefficient of viscosity is equal to 13.2 pascal second, would be nearly. So ball of a steel given is ball of a steel and terminal velocity, and we know that what is the terminal velocity. So terminal velocity is equal to, this is equal to 2r square into rho minus sigma upon 9 neta into g. So Vt is directly proportional to, this is equal to a square, no, so this is Vt is equal to, V2 is equal to, so what is V? Ball of a steel attains a terminal velocity of 10 centimeter per second when falling in water, and its terminal velocity ग्लिसरीन, दो लिक्विड है डिफरेंट, एक वाटर है और एक ग्लिसरीन है, तो रेडियस तो सेम ही होगा, विस्कोसिटी अलग अलग होगा और डेंसिटी जो है आपका अलग अलग होगा. तो अगर दोनों के लिए अलग अलग के लिए हम लिखें तो V डैश अपॉन, दिस इज इक्वल टू V, दिस इज द टर्मिनल वेलोसिटी, दिस इज द टर्मिनल वेलोसिटी इन डिफरेंट केसेस. सो दिस इज इक्वल टू 2r स्क्वायर, तो कैंसिल आउट हो जाएगा, जी कैंसिल आउट हो जाएगा, क्या बचेगा, रो माइनस रो डैश एल डिवाइडेड बाई रो माइनस रो एल इंटू नीटा अपॉन, दिस इज नीटा डैश. सो विस्कोसिटी वेलोसिटी इन ग्लिसरीन इक्वल टू, दिस इज इक्वल टू रो माइनस रो एल डैश अपॉन रो माइनस रो एल इंटू नीटा अपॉन नीटा डैश इंटू वी. सो अगर सभी वैल्यू यहाँ पे आप पुट करते हो तो वी डैश की वैल्यू 6.25 इंटू 10 पावर माइनस 4 सेंटीमीटर पर सेकेंड आपका आंसर आएगा. दिस इज द करेक्ट आंसर.